What's the difference between a fish and a guitar? You can't tune a fish. I slay me. All right, we're on to number 3 on our balanced versus unbalanced net forces worksheet. For number 3, I'm asking factories often use hydraulic cylinders to move things around. If a cylinder is moving a freshly cast iron mold with a mass of 550 kilograms, A, what acceleration would the cylinder have if it moved the object with a force of 5,505 newtons? And B, if it takes 0.12 seconds to move the mold into position, how far did the cylinder push the mold? So, to begin with, we are going to set up a variable list because this is clearly both a forces and kinematic problem. So, variable list, S, XI, VI, VF, A, T, force net, mass. Let's see, do we have any forces other than the net force in this problem? No. Well, so we've got the force of the hydraulic cylinder pushing. Let's go ahead and draw a free body diagram just to be sure. So we've got the freshly cast iron mold being pushed by a cylinder. So we've got a force acting on it this way. Well, obviously this iron mold is going to push back on the cylinder with an equal and opposite force. But other than that, and the force of weight, but we're not really going to factor that in yet, it doesn't look like we have any other forces, so we can just stick with the one F net variable. So then let's go ahead and put our numbers in for our variables. We've got a mass of 550 kilograms. We've got an F net of 5,505 newtons. And what else do we know? Okay, so that's what we're going to need to find the acceleration, but we also know it takes 0.12 seconds to move into position. And then we're going to find S. That's going to be how far it moved. Well, if all I want to know is how far a cylinder moved an iron mold, well, my starting position right here, that's going to be 0. Nice and simple. So, XI is going to equal 0 meters, and VI, before the cylinder starts pushing it, it is moving at 0. So, we're going to start at 0 meters per second. Perfect. And our velocity final? Who cares? We don't need to know. All right, so let's go ahead and calculate first our acceleration using Newton's second law. And that is F equals ma. Nice and simple. To find acceleration, we're going to do force divided by mass is equal to acceleration. So we'll do 5,505 divided by 550. That's going to get us 10.01 meters per second squared. We'll go ahead and put that in our variable list. Perfect. All right, everyone still with me? Good. So that is the first part that we're looking for. So we'll go ahead and put a box around that so that my instructor doesn't blow a gasket. And then we're going to find S, final displacement. What do we use to find that? Well, of course, the S formula. S equals xi plus vit plus 1/2 at squared. S is what we're looking for. Xi, 0. Vit, 0, because vi is 0. And then we have an acceleration, which we know, and a time, which we know. So let's go ahead and put in our numbers. 1/2, and our acceleration is 10.01 times time, which is 0.12, and that time will be squared. Let's go ahead and do that calculation. The results of that calculation are 0.072 meters. For those of you who care, that is going to be about 7.2 centimeters. So really not very far at all. It's just moving it into position so it can get liquid iron poured into it. So that's going to be an S of 0.072 meters. I want to put everything in terms of meters. Okay, perfect. Thanks, guys.